Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video we will discuss about this amazing paper by Microsoft, Florence-2. So Florence-2 is a lightweight vision language model which is capable of handling wide range of tasks based on simple instructions. These tasks can be image captioning or image segmentation, object detection, extracting text from images. So all these kinds of tasks we can perform with the help of Florence-2. So let's see the demo of this model first, then we'll understand the paper. This is the page. I have shared the link in description section. You can try this. Here we will upload the image and here the model is Florence-2. From this task prompt we'll select what we want to do. So let's start with the demo image. I am just uploading this image, and now you have to mention in this task prompt that what you want to do on this image. So these are the different tasks. So in this one, let's start with the object detection. So suppose I want to perform object detection on this image using Florence-2 large model. Click on submit and on this side you will see the output. See, horse, person, flag, these kinds of things are detected. Now let's try this model for some other task. On the same image only, let's try the image captioning model. Prompt is caption over here, detailed caption and more detailed caption. Let's click on this caption and click on submit. So in this side you are getting a caption. Now let's say we want to try a detailed caption. Let's select a detailed caption, click on submit, and on this side you can see a detailed caption. And now let's click on more detailed caption and click on submit. See, now you are getting this caption. So there are three types of options for captions only. Now let's try a different example. So I'm uploading this image and I'm mentioning here I'm providing two inputs to model. One is image, and with that image I want to provide some text also, and here the text is table in front of sofa. This is the text I have provided. Now what task I want to perform? So from here I'm writing region 2 segmentation. Region 2 segmentation means I have provided some text over here. On the basis of this, I want that model should pick the region which I'm describing over here and perform the task on it. And what task I want to perform? Let's say I want to perform segmentation. Region 2 segmentation, region we have mentioned here, and we have provided the input image, and this is the text we are providing to the model. Let's click on this. See, so you can see that table, we are getting a mask on the table. This is how you can perform various different tasks using Florence-2. And the key innovation of Florence-2 is its ability to handle tasks like object detection, captioning and detailed image analysis using a unified approach. So this is the official paper, Florence-2, advancing a unified representation for a variety of vision tasks. Now let's try to understand this paper. In the field of artificial general intelligence, people are using pre-trained models that can handle various tasks, right? And this trend initially successful in natural language processing with models like GPT-3. It is now influencing the domain of computer vision also. Unlike NLP, where models mainly handle text, computer vision deals with visual information such as identifying objects in the image, recognizing shapes and understanding the details like color and texture, right? So for computer vision models to be effective across different tasks, model need to understand both global concepts and the finer details. Global concepts means the overall scene understanding of the image, and finer details means pixel level details like recognizing individual objects and their exact shapes and positions. Okay, so this Dual understanding is important for creating versatile computer vision model that can accurately interpret and analyze visual information in various applications. Spatial hierarchy refers to the understanding of visual information at different scales or levels of detail within an image. It involves recognizing objects and their spatial relationship from a global context down to the specific details. Okay, so for example, in a scene where a person is riding a bicycle on a street, so spatial hierarchy would involve recognizing the street, bicycle and the person as distinct objects and understanding their positions relative to each other, and also knowing finer details like the texture of the road or the color of the bicycle. Semantic granularity refers to how much detail we can understand from visual information. So it ranges from getting a general idea of what's happening, like describing a scene with few words, to noticing a small specific details like identifying the color or specific models. So for example, in a street scene, it's not just about recognizing a person in a bicycle, but also noticing details such as what color clothes the person is wearing or what model the bicycle is. This level of detail helps in accurately describing and understanding the visual content. So to train Florence-2 effectively, researchers created a huge dataset called FLD5B. This dataset contains detailed information on 126 million images with 5.4 billion annotations. We'll discuss about this dataset in detail after some time. Okay. Now the next section is rethinking vision model pre-training. Now let's understand this section. What is there? Multitask learning. Now, what is this multitask learning? Multitask learning means teaching a model to do multiple related tasks at same time to improve its overall understanding and performance. And to create a strong foundation model for computer vision, researchers employ multitask learning. This approach involves setting up multiple learning objectives that are specifically designed to enhance the different aspects of visual comprehension. Let's discuss the few key objectives and how they contribute. So first one is image level understanding. So image level understanding means it recognizes what is in the image and describe it in words. So this involves two tasks: identifying objects in the image like a car or a tree, right? And then generates a caption that describes the whole scene. So like red car parked under a tree. Okay, so this is what image level understanding means. Then we have region pixel level recognition. This objective aims to accurately identify and localize objects within the image. It will not only identify objects, but it will also precisely outline where each object is in the image. And tasks in this category include object detection, means putting bounding boxes on the objects in the image, and then image segmentation, where we put a mask on the images. Okay, so these kind of tasks comes under this category. And then the third one is fine-grained visual semantic alignment tasks. Now these tasks require detailed understanding of both textual understanding and the visual elements. So they involve pinpointing which part of an image correspond to specific text phrases. For example, given a description that says a person riding a bicycle, so the model should accurately pinpoint the exact area in the image where the person and bicycle are located. Okay, so in multitask learning, the model learned to handle all these three tasks simultaneously. So by training on variety of tasks like these, the model become more capable, and it can do things like describing objects in the image, describing scenes accurately, and then understanding how the objects relate to each other. So when the model learn all these tasks together, it does not just get good at one thing like spotting objects, like detecting objects or writing captions. It gains a wider and deeper understanding of images overall. This method is crucial for making smarter computer vision systems that can be used in lots of ways, like in self-driving cars or in medical technology, right? So this is what this multitask learning is. Now let's talk about this part. Third, model. Florence-2 is a model designed for universal representation learning in computer vision. Now what is universal representation learning? It means training a single model that can understand different type of information without needing a task specific adjustments or retraining. Okay, so Florence-2 is designed to handle multiple vision tasks using a single set of weights and a unified architecture. This means that instead of creating a separate models for tasks like image classification, object detection or image captioning, Florence-2 can perform all these tasks with the same underlying model. So Florence-2 use a sequence to sequence learning approach. Okay, so this approach commonly used in natural language processing tasks. Let's try to understand this image. So Florence-2 work by taking image and the task instructions, which are prompts, okay, as input, and it uses a vision encoder to turn images into a visual embeddings, okay, and then which are then combined with the text embeddings, and these combined embeddings go through a transformer based encoder decoder to produce a final output. Okay, and depending upon the task, the prompt and the response can either be text or region. So for example, if you are providing a simple text prompt, it will directly process them in the sequence to sequence format. But if you are providing image and text, so region specific tasks. So for region specific task where you provide image and text to model, like tasks like object detection and segmentation, right? So for those tasks, Florence-2 use location tokens. So location tokens are special tokens that are added to the model's vocabulary to handle the specific region within the image. So for example, here you can see, as I've told you, if you'll provide text input, so you will get a output in the format of sequence to sequence format. But if you are providing a region specific detail, like over here I have mentioned a proper region, that wooden table in front of sofa, so I'm talking about this region over here. Okay, so for these kinds of tasks, Florence-2 use location tokens which are specifically used to handle the location of the objects in the images. Okay, so the first one is box representation. What it does, box representation is used for tasks like object detection, where tokens represents the coordinate of the bounding box around the object. Here you can see these are the bounding box coordinates, so these are the tokens when you are working on object detection problem. So these will be the location tokens. Okay, and then we have quad box representation. Now what is it? So they are used for text detection. Whenever we want to detect text in the images, quad box representation is used for that. And then we have a polygon representation. So this is used for tasks like segmentation, where tokens represent the vertices of a polygon outlining a segmented area. So by adding these location tokens into the vocabulary, Florence-2 can process region specific information uniformly across different tasks without needing a task specific modifications. So Florence-2 model is trained using a standard language modeling techniques like cross entropy loss. This ensures that the model learn to generate accurate and a contextually relevant output based on the input image and the task prompts. So this is what this section is, a model section tells. Okay, now let's talk about this data engine. So Florence-2 is trained on FLD5B dataset. FLD5B dataset includes 126 million images, 500 million text annotations, and 1.3 billion annotations linking text to specific image region. This extensive dataset covers various aspects of image understanding, enabling Florence-2 to learn diverse tasks effectively. Now let's talk about this image collection process. Let's see how they collected images for FLD5B dataset. So the image collection process began by identifying three main tasks that generate a lot of data about the images: classifying images into category, detecting objects within the image, and describing image with the captions. So they collected dataset from 5 different datasets. So they collected data from ImageNet 22K dataset, and then Object 365, Open Images, and then Conceptual Captions, then Leon. So these are the 5 datasets. By putting together these 5 datasets, they created one big collection containing a total of 126 million images. So this approach ensured that they had a variety of images with different types of information, like having classification labels, object bounding boxes, and descriptive captions. So once they collect the dataset, what is the next task? To annotate the dataset, right? So now let's talk about the data annotation. So in this section, they outlined a detailed process for annotating a massive dataset of 126 million images. So they have done 3 main type of annotations. One is text annotation, second is region text pair annotation, and the third is text phrase region triplets. The first one is text annotation. Text annotation categorize images based on different levels of detail, from brief descriptions to more detailed narratives. Remember here we have used, if we talk in this section while checking the demo, caption, detailed caption, and more detailed captions. So we have 3 different kind of text over here. So these are the 3 different kind of text annotations they have. So that's what they are talking about over here. Okay. So text annotations are categorized into 3 levels of detail: brief text, detailed text, and more detailed text. Second one is region text pair. Region text pairs provide textual description for specific region within the image. These regions can include both visual objects and text within the image. For example, a wooden coffee table in front of the sofa. So here you can again see same example only. A wooden coffee table in front of the sofa. This is the text and this is the image. Region text annotation. So we are defining a text, and in that text we are defining the region, and this is the image. So these kind of annotations. Okay. Third one is text phrase region triplets. Text phrase region triplets combine descriptive text, noun phrases related to the image objects, and annotations for these objects. Okay. So this annotation process has several phases to make sure that annotations are correct and complete. So the initial annotation is, okay, let's see this image. Okay, figure 3. In this image you can see the first thing is initial annotation. So in this initial annotation phase, they used AI models which are trained on different datasets to create initial annotations for each type of annotations. So for example, image to text models, they used image to text models for generating brief texts, and then they used object detectors for bounding boxes, and they used OCR tools that can read text in the images. So this is the initial annotation process. And after that they have data filtering. In data filtering, what they does in data filtering, if you will see the text filters and the region filters. Text filter is for text annotations and region filtering is for region annotations. So let's talk about the text annotation first, text filter first. Okay, so over here they used tools like Spacey to parse and filter out irrelevant objects and actions from the text. Okay, and then they have region filtering. Over here they applied confidence thresholds and non-mix suppression to bounding boxes to eliminate noisy or overlapping annotations. And then they are using iterative dataset refinement, and in this step they trained the model iteratively on the refined annotations to improve the prediction accuracy and to reduce the noise. They then used the refined dataset to further train models specifically for tasks with sparse initial data, enhancing overall performance. So this detailed annotation process ensures that the FLD5B dataset is properly labeled across different level of granularity, enhancing its utility for advanced AI applications such as image understanding, object detection, and scene comprehension. So this approach not only improves the model accuracy, but it also supports complex tasks that require proper understanding of visual content. That's what they have performed in data annotation. After that, now experiment section. So now let's see what they have done in this. So they conducted an experiment, and in this experiment they trained Florence-2 model on FLD5B dataset to learn a universal image representation. So these experiments are structured into three main parts. First one is zero-shot performance evaluation. In this part, the goal is to evaluate how well Florence-2 model can perform on various tasks without any additional fine-tuning on the task-specific dataset. Okay, this shows that the model inherit capability to handle multiple tasks using a single generalized model. Okay, then second one is adaptability with additional data. So what it means is that after evaluating zero-shot performance, the model are further trained with additional supervised data across a wide range of tasks. So the objective here is to show how the Florence-2 model can adapt and improve their performance when trained with more task-specific data. And the third one is backbone performance evaluation. So the final part of the experiment is this only, the backbone performance evaluation. This experiment focuses on assessing the performance of the learned visual representations on different tasks. Here the Florence-2 models serves as the backbone model for these tasks, aiming to demonstrate that their pre-training method outperforms previous approaches in terms of effectiveness and versatility. Now let's talk about the setup, like which model they used, what are the parameters they have used to run this experiment. So this Florence-2 model have two variants. So Florence-2B means the base model, which have 232 million parameters, and then there is another variant which is Florence-2L model, which is a large model and with 771 million parameters. Weights of the image encoder are initialized from the UniCL, and while the multi-modality encoder-decoder weights are initialized from the BART. So what is weight initialization? Weight initialization is the process of setting initial values for the weights and parameters of the model before training begins. And the choice of initialization method can significantly impact how well your model learned during training. So why initialization matter? Because initializing weights from pre-trained models like UniCL and BART is beneficial because it leverages knowledge learned from large datasets and tasks similar to those the Florence model aims to perform. So this approach can lead to faster convergence during training and potentially better performance on downstream tasks. Next is this zero-shot evaluation across tasks. Now let's talk about this. So in this section, author discusses the performance of their Florence-2 model without any task-specific fine-tuning. and here we can see the key achievements also over here, right? In table number 4 here you can see for image level tasks like Coco caption, Florence-2 achieve a CIDR score of 135.6 on the Coco caption benchmark. This score is noteworthy because it surpasses the performance of Flamingo 80 billion model, right, which achieved 84.3 CIDR score. And you can also note here that Florence-2 uses fewer parameters as compared to the Flamingo. Flamingo model have 80 billion parameters and Florence-2 model have 77 billion parameters. But then also it achieved 135.6 CIDR score and Flamingo model achieved 84.3 CIDR score. Like this you can see other comparisons also in this table. Okay, now let's talk about the next section, which is downstream tasks fine-tuning. So in this section the author discussed how their Florence-2 model perform when they fine-tuned on specific tasks after its initial pre-training. So over here for this they have used a base size model with around 80 million settings for fair comparisons with the other techniques. So this process involves taking a pre-trained model and adapting it to perform specific tasks without starting from scratch. The test result shows that after pre-training Florence-2 with universal image understanding approach, fine-tuning it on specific tasks like object detection and segmentation leads to superior performance as compared to the previous methods. Let's talk about the results. Okay, so here you can see that the Florence-2 base model shows significant improvement over other approaches. So for instance, while testing on this MaskR CNN for object detection, Florence-2 David B model achieves 0.7 points higher in average precision compared to ConNext V2B. Right? Even though Florence-2 uses a shorter training schedule, Florence-2 was trained for 12 epochs only, and ConNext V2B uses a 36 epochs to get training, but still the performance of Florence-2 is better, right? Let's talk about the training efficiency, right? So Florence-2 pre-training method proves to be more efficient during training compared to models pre-trained on supervised like ImageNet 1K data. Right? Especially Florence-2 achieves 4 times the efficiency and a notable improvement of 6.9 average precision and 5.5 average precision in object detection tasks using MaskR CNN and Dino framework. So in the same way, if you'll see the semantic segmentation experiment also over here, the ARPANET framework on the AD20K dataset, in this case also the Florence-2's David B backbone achieves notable improvements. So overall this section 6.4 shows that the Florence-2 model demonstrates superior performance across various tasks, showing efficiency in training and then strong generic representation capabilities and significant improvements in object detection and semantic segmentation tasks when we compared it to previous methods. Okay, so the next one is ablation studies. So in this study the goal was to find out which pre-trained model work best for transferring knowledge to different types of tasks in computer visions. 3 models were compared, each pre-trained on different combinations of tasks. So the first one is image level model. So this model was only pre-trained on tasks related to understanding the images broadly, okay, like the image classification tasks. Okay, and then the second type of model is image region model. This model was pre-trained on both image level tasks and the tasks that involve understanding specific regions within the image. And then the third type of the model is image region pixel model. This model was pre-trained on tasks at 3 levels: image level, region level means understanding the part of the images, and pixel level means identifying details within the part of the images. So the third model, which is image region pixel model. This model was trained at 3 levels: image level, region level and the pixel level, and these 3 models were tested on a dataset containing 4 types of tasks. First task is COCO caption, second task is COCO object detection, third task is flicker 30K grounding, and the fourth task is ref COCO referring segmentation. So all these models were tested on these 4 tasks, and the key findings are that the image region pixel model performed the best across all the tasks, all the 4 tasks compared to other models. So this model was the best, the image region pixel model. That's it guys, this is what I have studied till now about this paper, and I hope my video is helpful. And guys, if you like my content, please like, share and subscribe my channel. Thank you for watching.